Welcome to Ballbusters Live. I'm your host Nathan Oakley, and if you're new to this channel, or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you'd like to support this channel, there is a super chat that runs alongside each of these shows while they're live. There's also a PayPal, Patreon and crypto link in the info box below this video. Now joining me this evening we have Slick James Johnson, Quantum Eraser and Betty Van Velsen. How are you all doing?
Hello, good afternoon.
Hello, good evening.
Good afternoon, sir.
Very good to have you all. So today's subject, in case the title didn't give it away, is the nonsense of gravity. And this is I described it as a stale fart that won't go away on one of the debates recently, and I think that's fairly apt because it does stink. So who wants to kick off? Nobody. Very encouraging.
Well, it's a fairy tale, isn't it? So just a name.
It's kind of hard to kick something off that doesn't exist. Naturally, you're going to draw crickets.
Well, before the show started, we were talking about the equivocation of the law of gravitation. I don't know if that's going to be halfway through the presentation that John does in a moment, but ultimately speaking, that's just simply not the case. So we don't observe gravity. We don't see mass attracting mass. We don't see the bending of space-time. None of this is actually occurring. So why would it ever be labelled a law?
Yeah, it's just that observe and declare thing. They see something move and automatically attribute a force to it and then build a world around that declaration and push it for many, many years until it becomes law.
Well, if you repeat something over and over and over again, then people tend to adopt it no matter how crazy it is, correct?
Yeah, look at the heliocentric model. I mean, that's a perfect example.
Well, I think it began with in the education system, they tried to explain why the world was a ball, and that they had to explain somehow that if you are stuck to a ball, that you have to have gravity to keep you there, right? So that's the start of that fairy tale, I think, because they made us believe that if you were on a flat plane, that you fall off the edges. So that's where it began, and then they added on to the whole gravity tale, I think, all the other things with the planets, the orbits, and all the rest of the fairy tale of the heliocentric model. So I think there it's all began.
But when you ask somebody about it, they'll tell you about 9.8 meters per second and express it like it happens everywhere. And then when you dig into the nitty-gritty of it, they explain how that if they suck all the air out of a chamber and then drop two items, they'll both go down. In other words, the aspect of relative density, the thing that actually dictates which direction something's going to be travelling in, based on its medium, is completely removed. And then you're left with this figure that's attributed to a downward force at 9.8 meters per second. And it's an effect to start with, but they describe it as a cause, right? They describe it as gravity.
Exactly.
Yeah, but with the laws of, for example, the law of thermodynamics. I mean, heat always goes to cold, right? So that's something that is. It happens. We cannot never ever find out the cause. So maybe we will never find out the cause why things drop to the floor, for real. If we just see the effect of it.
Right. The thing about hot going from cold, you can at least measure the temperature, But with their force, it's just never. You can't. All you can do is imagine it. You can't ever really verify it. You might say.
Yeah, well, you can measure maybe how fast a bullet a ball will fall instead of a feather, right? That's something with inertia and stuff. But then you get into the mass, and I think that John will have to explain a lot of things about what mass is not mass and how it's explained. or it cannot be explained.
I think the thing that they miss is that they're not sure of all the variables involved. Have you isolated all the variables before you come up with this, declared law, so I think that's one of the things they're missing.
Yep.
Well, thank you. That's great. Well, that's the presentation. Thanks for coming.
That's it. We're done. Thanks for watching. Hope you all shared. No, but seriously. So,
well, if it was that easy, I think the message would already be there, right? So.
Well, the thing is, it's so easy to, it's not one of those things that's really difficult to show that it's just an imaginative, something made up. So it's not that hard.
Well, you see when you have to battle people with their fairy tale. I mean, I've made many a comment in comment sections, and what they come back with, it astounds you. So, yeah.
Well, a lot of the responses is, guess what? Gravity. Gravity, it's the savior. It saves the day on many a front, doesn't it?
Yeah, big G.
Yeah. I can hear Rumpus somewhere right now going, "You utter, you just don't understand. You don't understand." So, yeah. I'm sure we're missing something.
Yeah, I like it particularly when it's used as a band-aid for the violation that's known as the vacuum of the sky, and they assert that gravity is the be-all and end-all solution to that problem, i.e. a second law of thermodynamics violation, the gas not filling the space that's available to it if you believe the sky is a vacuum. And then you'll hear the assertion, well, gravity is a container. It's like, wow, this gravity thing could do basically anything, can't it? Hold all the oceans.
Yeah, it's a shapeshifter, boy.
That's it. Magical container that is gravity. But in that instance, you can, because it's just a fundamentalist belief, it doesn't really exist. And I got this from you, John. I watched you do it. I think it was on Anthony's show. You said, I'll give you both. You can have Newtonian Cavendish and Einsteinian gravity at full effect. Now show me gas pressure without a container. It's like, what are they going to do with that? Oh yeah, thanks for the concession of gravity. Yeah, I still can't show you gas pressure without a container though.
I was just, right before you said it, I was just thinking that. Yeah, both at full force, full effect. I'll give them both to you, right? Grant, your fairy tale will never overcome entropy. Never. You will never hear anybody say that besides ballers.
I hope the other thing that gets covered on today's show will be the declaration that Einsteinian gravity somehow incorporates Cavendish gravity.
Oh, yeah, it's getting mentioned.
Excellent. So we'll be into the pseudo-Romanian force space at some stage.
Oh, yeah.
Excellent. Right, should we kick it off, John? What do you reckon?
Yeah, I reckon so.
Excellent. Right, I'll bring up here the hangout. Hopefully you're presented. We shall see.
I just hit it. Let me know when it's out.
Yep, you're up and the audience can see you.
All right. Well, we're going to start out with Newtonian Cavendish gravity. And there's a reason why I do this, why I state both of these guys, because I don't want to lay this solely at the feet of Newton. And you're going to see that over the next couple statements that we talk about. I just think that a lot of things were attributed to him that maybe he wasn't responsible for. That's what it sounds like to me. We could talk about it after this section. But just for gravity's sake, now I'm going to take Newton to the woodshed here in a little bit, but not for gravity. But in this particular instance, and let's take a look at this. This is from a letter from Dr. Richard Bentley on February 25th, 1692. And this is about 5 years after the publishing of the Principia. And before we get into it, notice this term over here. He's already talking about a vacuum, right? In 1692. How do you know that? That's a question I have. Maybe somebody can answer that question down the line, but I'd like an answer to that. However, like I said in a letter to Dr. Richard Bentley on February 25th, 1692, Isaac Newton says, 'tis inconceivable that inanimate, brute matter should, without mediation of something else, which is not material, operate upon and affect other matter without mutual contact. That gravity should be innate, inherent, and essential to matter, so that one body can act upon another at a distance through a vacuum without mediation of anything else, by and through which their action or force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into. This is a striking statement. Number one, he's essentially saying that the concept of gravity is absurd. And number two, if anyone is even entertaining this, then their faculty of reason should be brought into question. So you guys see, that's the cross. This is one of the cross currents that I have with, oh, Newton proposed this and that it just doesn't line up. Right? I don't know. Maybe I'm interpreting this wrong. You know, like that's what some people say. Oh, you interpret it wrong. I don't think so. But we could talk about that here in a few seconds. Let's get on to the next one. This is really important. So the gravity hypothesis, and we were struck with this the other day on the show. So from the Principia, I have not as yet been able to discover the reason for these properties of gravity from phenomena. And I do not feign hypotheses. That means I do not contrive a hypothesis about gravity. He says it right in the Principia. He makes no hypothesis because he can't. It's nonsensical. It's not science. From one of the pseudoscience high priests, Sean Carroll, from nature.com. Listen carefully. California Institute of Technology physicist Sean Carroll, arguing in The Edge. Hypotheses aren't simply useful tools in some potentially outmoded vision of science. They're the whole point, right? Even Sean knows that. So Sean, Newton said he has no hypothesis for gravity. And you just said above that hypotheses are the whole point. I have a question. How can it be friggin' scientific then? I'd like to know their answer to that question. Moreover, the Ballers scientific community, aka the pseudo-scientific non-community, doesn't even follow Newtonian or Cavendish gravity, right? From George Musser and Scientific American, and he's a PhD astrophysicist, by the way. Einstein created his general theory of relativity, which provides our modern understanding of gravity. We all know this. Any freshman physics student knows this. With the express purpose of expunging non-locality from physics. Isaac Newton's gravity acted at a distance as if by magic, and general relativity snapped the wand in two by showing that the curvature of space-time and not an invisible force gives rise to gravitational attraction. Now, I've seen this citation brought up on many occasions, and the Ballers just bumble, and stumble, and make all kind of assertions regarding it. This is cut and dry, right? Now, I color-coded these up here. You see Isaac Newton's gravity, and by magic, and snap the wand in two. See, they're talking about Isaac Newton's gravity. So what wand? Well, the magic wand. Where's the magic? Well, that's Isaac Newton's gravity. And then it says, by showing that the curvature of space-time and not an invisible force gives rise to gravitational attraction. So what's the problem here? Why are people calling this a force? I don't know, what is it? Do people have problems with the word not? I mean, you're going to have to go define not or something, because I don't see what the big problem is. What, Scientific American is not a scientific journal? Well, what makes a science journal scientific to begin with? Right? We talked about this last week. Well, it's got to follow the scientific method. How many journals follow the scientific method wholly? Not too many, since 99% of them, 99% of the studies in them don't have any science. So you really don't have an argument here, right? And like I said, George Musser, he's a highly respected guy in the scientific community. He's been writing for Scientific American for years. All he does is summarize all of the other journals. That's all they do. There's nothing wrong with this. It's not an invisible force. Einstein snapped the wand in two. That means no more Newtonian or Cavendish gravity. This is real easy, right? So you won't accept that. Okay. I'm going to get medieval on you. Let's go to Caltech. Einstein came up with the theory of general relativity in 1915, the prototype of all modern gravitational theories. Its crucial ingredient involving a colossal intellectual jump is the concept of gravitation, not as a force, but as a manifestation of the curvature of space-time. Can anyone tell me what the difference is between these two? Not much, right? So I don't know what your problem is. This is real easy to reconcile. Better get your act together. Then we have another pseudoscientific priest, Brian Cox. That comes right on. There isn't really a force of gravity at all. Why are we continuing to hear day after day about forces of gravity? You're not even parroting the right pseudoscience. For goodness sakes. I mean, at least you could do is parrot the right one. Gravity is not a force. Period. End of story. And you can't reconcile it. You can't say it's a force or it's not a force, and then in the next statement say it's a force. I heard that the other day. Say it's a farce, maybe. So we got Newtonian Cavendish and Weird Al's gravity. That's what they do. They come back. Some of them realize that, okay, boy, they got me up here with this force stuff. So we got to pivot. We got to make something up, because that's what you do. You just make it up as you go. Like we don't know that you're doing that. Right? Newtonian gravity or Cavendish gravity is not the same as Einsteinian gravity. Number one, scientific theories never, ever explain laws. Never. If they did, it wouldn't be a law anymore. Newtonian gravity and Einstein gravity are mutually exclusive. Newtonian gravity is a force. Here we go again. Einsteinian gravity is not a force. It's cut and dry. That one's over. They're not even in the same geometry, for crying out loud. How in the world can Einstein equations reduce to Newtonian equations when they're not even in the same geometry? Can you show me that trick? Right? I'd like to see that one. Newtonian gravity speaks to instantaneous actions at a distance, whereas Einsteinian gravity is limited to the speed of light. I mean, drunken sailors and field goal posts have more in common than Newton and Einstein's fairy tales. So I don't know. You guys better get another story, because this is a belly laugher. And I want somebody to take Einstein's field equations. I want to reduce them to Newtonian equations in front of us. I want to see that little maneuver.
He can't.
Yeah, that's right. They can't.
So let me get it straight. So
let's stop. We'll stop it right there. Go ahead.
I was going to say Newton himself is saying essentially that you've not got, how did he phrase it? Good cognitive faculties, if you were to consider this. How did he phrase it?
So he said, so it's so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into.
And that's him talking specifically about gravity.
Yep.
That's Newton. So why have you got it as Newton Cavendish? Because maybe you could just strike Newton off. You know what I mean?
Yeah, I do it because that's what most people think, that, you know, they relate the two. I don't want to have Newton in here, but I do it just for familiarity, so we know what everyone's talking about. That's why I do it.
Certainly Betty always calls it Cavendish gravity.
Yeah. Well, Newton has these other laws about motion and stuff, and people think that also has something to do with it, right?
Oh, we're gonna get to those.
Yeah. And I want to go to that quote with the 1 and 2 breaking stuff. Can you go there?
Oh, snap the wand in two.
Yeah. And that thing that they say that Einstein was showing that the curvature of space-time and not an invisible force gives rise to gravitational attraction. And how did he show that to us? That's what
He
I'm
didn't.
interested in. Yeah, well, but they say it in this article, and then I think, well, okay.
Yeah, that's a subject for another time. But what we're trying to point out is that their scientific community, what he's reporting on here is that they follow Newtonian gravity and not, or they follow Einsteinian gravity and not Newtonian gravity. That's the point.
Yeah, so we basically replacing one magic with another magic.
Oh yeah, we'll get to the other magic. We're gonna pummel one at a time.
Yeah. Oh, I like that it says that showing, and I think, well, I've never seen anyone show that to me, but yeah, it's an interesting phrase there.
You know, it seems like already in the conversation, gravity has been hit and its knees are already buckling, and the fight is just, the bell just rung, and gravity is already about to go down. I mean, how did it ever get this far? That's interesting.
It's a build up, I think. Yeah, because, well, how did he know that there was a vacuum to begin with, right? So they build it up on something that it's like it's being planned, basically.
Yeah, that wasn't a rhetorical question. I want to know how they knew, how Newton knew, or when did they know that there was a vacuum of space? I'd like to know that.
Well, what are you implying? Are you implying that the narrative's been altered?
Now, I'm not implying that. I find it very interesting that in 1692 that they knew there was a vacuum. So
or
I'm not
alleged to
implying
know.
anything with it. Nope.
Yeah, that's interesting. Also, can you explain the difference between Euclidean and that pseudo-Riemannian four space?
Yeah, I just did. Euclidean three space is just like as we know it, as we live in reality. Length, width, depth, and pseudo-Riemannian four space, it's length, width, depth, and they add time on this. So that's what makes it pseudo-Riemannian.
Yep.
Cool. Anything else by anyone else? If not, hopefully we'll move on.
Yeah.
We good?
So,
Go ahead.
Okay, so like I said, why on earth are you still appealing to Newtonian or Cavendish gravity? Right? All that these Wikipedias are doing is taking an effect that's things fall to the ground at 9.81 meters per second squared, which is bullshit to begin with. I don't even care. I'll just let you have this bullshit. I'll do an Anthony. You can even have this bullshit. I don't care. And then conclude by mere declaration, gravity is the cause. Well, you can't do that. That's non sequitur. You have no connection there. So they use the value 9.81 meters per second squared and put it into the fairy tale descriptive equations and say it works. Then say, voila, gravity exists. You can't do that. The attribution or cause of this effect has not been identified or isolated, and never will be scientifically validated. So you can't do that. You're just observing an effect. And even that I put into question. But what did we get? Well, Newton never proposed a hypothesis for his law. Okay, well, that's okay. We have the ballers here to produce it for him. What is it? Mass attracting mass, right? This is what we get on the show. How many times have we done this? And pummeled it every single time, but we continue to get it, right? Hypothesis. Listen to this one. If mass, then mass attracts mass. This is what we get. I mean, they could have colorful language around it and use other terms, but eventually we get down to this. If mass, then mass attracts mass. I mean, this is a Mr. Magoo circle jerk of the millennium, right? This is ridiculous. Just on its face, I don't even have to go anymore. Independent variables mass, dependent variables mass attracts mass. I mean, they need to look up, along with not circular reasoning. Titus Vetus, this is your actual hypothesis, this guy right here. If gravity exists, then larger masses will attract smaller masses. That's your hypothesis. You know, you could try to weasel out of it, but that's what it is. But you know what this is, right? You're attempting to prove something, right? That's in one of your premises. You can't have it in your premise if you're attempting to prove it, right? It's part of your conclusion. That's begging the question. And if you take the whole thing, it's a simple affirming the consequent form of logical fallacy. Set. Have a nice day. And by the way, if you put this forward as a hypothesis, you'd fail 5th grade general science and the 60 level basic reasoning course. All right, let's get to this one. Usually, I brought this up initially a few months ago, and then I said, you know what, I'm not bringing it up anymore because we get bogged down, you know, with the details. I like to do it because I think it's funny, but we can't bring this up on the show because it takes 3 hours just to get through the hypothesis. So every time somebody says mass, I cringe, but I don't say anything. But here I'm going to bring it up, and you're going to see how funny this is. So, and then of course we get the appeals that, well, this is just semantics, right? Only this is a semantical argument. Well, isn't everything? I mean, isn't that the Socratic method? You need to look up Socratic method with your knots, okay? So what do we got? Let's look at physics about. Words have precise meanings in science. This shouldn't surprise anyone. I mean, science deals with precision and accuracy. You have to define words precisely. Dr. Mary Schweitzer, paleontologist, North Carolina State. Exactly. That's one of the things I drive my students crazy on. Words count. Words are important. Choose your words carefully. Right? You guys get this? Hello? Train wreck appeals you guys have. You need new arguments. So let's take a look at this. I pulled these both from Wiki. Let's take a look. We got mass and inertia. So from Wiki, mass is both a property of a physical body and a measure of its resistance to acceleration. A change in its state of what? Motion when a net force is applied. So no problem. But rot-row, Shaggy, we look up inertia. What does it say? Inertia is the resistance of any physical object to any change in its velocity. This includes changes to the object's speed or direction of what? Motion. These two definitions are the same. You can't have one definition for two different words, people. Okay? It's non sequitur. So what do? So you got to weasel your way out here somewhere. You should come up here. Oh, look at this. It says acceleration. And this one says velocity. QE, you don't even know what you're talking about. They're different, right? Oh, really? Velocity of an object refers to the speed in a specific direction. Velocity is nothing but the rate of change of displacement. On the other hand, acceleration is the rate of change of velocity with respect to time. And you can look at the units of measure for each of these. Acceleration is meters per second squared. Velocity is meters per second. If you're traveling at a constant rate, you have a velocity but no acceleration. If you're traveling and your rate is changing, you have velocity and acceleration. That's lovely. But you know what? Who really cares? This is the compelling factor in the matter. If something is accelerating, does it have motion? Yeah. If something has velocity, does it have motion? Yeah. I mean, this is an ongoing, unmitigated train wreck of a disaster. These two definitions are the same. And anyone can see that. So stop your weaseling. Here's the next one. Here's the next train wreck. Now we got even more definitions. So the definition of mass number 2 from New York University. Mass is a measurement of the amount of matter something contains, right? Ruh-roh, Shaggy. The mole became part of the International System of Units in 1971. Currently, it is defined as the amount of substance that contains as many entities as there are in 12 kilograms or 0.12 whatever of carbon-12. It's based on carbon-12, right? So what they do is, because this is a specific measurement, right? They say that they're different. No. Look at the root definition. The amount of matter something contains, the amount of substance something contains. The root definition is the same. Just because they have a specific amount here doesn't change the root definition. They're still talking about the same thing. They're the same. Moreover, from the Royal Society of Chemistry, the studies have shown that the amount of substance is often incorrectly identified with mass. So we got cross currents here till the cows come home. And by the way, the new definition of a mole, it takes out the relationship to carbon-12 and just goes with elementary entities. I mean, the tangle webs you mindless parroters weave. Right? All right, we could stop here.
Been joined by Adam. How you doing, Adam?
Evening, everyone. I just did a little bit about moles.
Moles?
Yeah.
Are we talking molecules or underground tunneling?
We're talking about molecules, man. But there's another mole, right? There's one that goes deep inside another organization, right? It's like a double agent.
That's why I'm here.
So what do you think about this? What do you think about this, Adam, between these two definitions right here, between mass and mole?
The mass is the bitch, isn't it? Moles, I understand because it's quantifiable. Mass is the one that, to me, my old lecturers, it's like when you're a kid, A-levels or just starting your degree, this concept that's introduced between there's a difference between mass and weight is hard. Certainly as a pharmacist, when we're making stuff and we're talking mass and we're talking weight, and I go to a set of scales and I weigh things out, which is a weight, but my calculation is in moles, which is mass related. And the basic way we were given it at first year of university was, like, it's just weight. Weight is mass. It's the same thing. It's just made up to fit into a secondary concept so you can put it into that secondary concept. The two things are the same. It's just that weight then has been re-described and SI united to include multiplication by 9.8, but it's the same thing. Certainly from a pharmacy point of view, in terms of the way we deal with the things, there is no difference because nobody has been anywhere else to prove that mass has a different weight somewhere else.
Hey, this is just sorry to put you on the spot there, Adam, because you just came in. This is the second definition of mass in its comparison with the mole. You missed the first one.
Oh, sorry.
No, it's not your fault. We had mass and inertia. These two are the same definitions. Again.
Isn't inertia?
The only difference is down here is they mentioned velocity. The only difference between these two definitions are acceleration and velocity, but that's irrelevant to the dang definitions, right? Because we're talking about motion. See, this is the key term. Resistance to motion. It's motion, not these. Motion.
Yeah, motion. Both inertia and acceleration have motion. It's just inertia or standard speed velocity is one fixed speed, whereas acceleration is an increasing speed, but both have motion. Therefore, if you're going to describe something's attribute as motion, which is what they do, then they're the same thing. It's irrelevant whether it's speeding up, slowing down. It has motion.
Yep, that's what I said. Yep. Thank you very much. Yep.
Okay, well, I'm quite slow, so I don't follow how this ties into gravity at all. I don't get this. You're going to have to dumb it down for me a little bit.
Well, it doesn't, because I'm only whistling past the graveyard, because this has Newtonian Cavendish forces and stuff with mass, correct? So I'm just whistling past the grave. Like I said, this is just a bonus pummeling. because we're not following, according to the pseudoscience religions, they don't follow Newtonian gravity. So I'm just whistling past the graveyard here.
No, that's not what I mean. I want dumbing down. I mean the multiple definitions of mole, mass, and inertia.
Which I don't know. It's just for confusion, I guess. Like Adam was saying, it's confusing.
Well, I was hoping it would lead on to the 9.8 that they weasel in there.
9.8.
That's the way I've always understood it, Nathan, is that mass we can treat as mass, but if we want to, we can treat weight as mass and call it and define it in standard units of kilograms. But if we want to get into Newtonian bollock newtons, which is just another made up unit, which is mass times 9.8, then we start to describe things in terms of newtons, which is weight, which is a description of the only experience we've ever had, which is mass, expressed as a function of a downward accelerating force, which it's been divided by to give you a new unit, which is just kilograms times 9.8. Basically, is the mathematical way I've always dealt with it in terms of comprehension of what you're dealing with. Forget the bullshit way of trying to re-describe it. It is literally just that, and just a new way of describing mass as weight by multiplying it by 9.8 and giving it a different unit name as a newton. But that's all it is.
And why would you want to do that? What is that useful for? If you are
useful
say again,
be useful for reinforcing something that has no relevance to reality, wouldn't it?
What's that? I'm desperately trying to lead you.
The good way of describing it is ships, isn't it? Is the way it was initially invented. When you load a ship, you load it in newtons, and the way you calculate the newtons is you take the weight and you multiply it by 9.8, and then when you dock at the other place, you take the weight, take the newtons, and then you take the stuff off, you weigh it, and you multiply it by 9.8, and you confirm that the cargo is the same. It's just another step of redefining the units so that those units have some relation to gravity. Is the only way in which I can see the bastardization of the initial word of weight has been changed to have a separate meaning to the universal interchangeable thing of mass. And certainly from a pharmacist's point of view, weight and mass, when I'm dealing with stuff and I'm making medicines, it's the same thing. Because I've never gone and weighed out a recipe for a medication on the moon. So I've never had to adjust weight and mass because they are the same thing to me in the physical chemistry world.
So sorry to lead you again. So you mentioned about weighing things on the moon and how we've got this introduction of the Newton in order to incorporate this 9.8 meters per second. So then how does that link to the moon? I'm trying to get you to link it and round it out so that it's nice and clear how this affects the heliocentric bullshit world. That's what I'm trying to lead you to do.
I've got you. We're instead of taking weight and mass as the thing that we all observe and experience and can comprehend, we try and pervert this into a new Newtonian understanding of the difference between weight and mass, so that weight actually becomes the effect of a downward force as opposed to a redistribution based on relative density, and an expression of intramolecular forces is actually down to some invisible force or the bending of space-time.
Beautifully put. Has anybody else got anything to add? If not, maybe John, we can carry on. Slick, Betty.
Well, I can make it a little bit more confusing, because I'm just sitting here thinking, now, I'm no expert on gravity, because the whole thing to me sounds like a self-perpetuating circle jerk, on steroids. But when you take a car, let's say a car, force equals mass time acceleration, right? Now, so a car moves sideways with a force. Now, it just seems like I can easily explain that same mass and acceleration if I was to say pick up a bowling ball. It's going to take energy to pick the bowling ball up. And when I release it, I'm still also getting mass times acceleration. Now, that's attributed to gravity, but when the car uses mass time acceleration, it has nothing to do with gravity. So like I said, I'm sure I'm missing something, but that confuses me.
Out to Colin Turner for hitting the super chat. Really appreciate your support. Did you have anything to add, Betty? If not, we'll move on.
Yeah, it's also a language thing with me. Everybody can say something about the definitions, and yeah, I have to go back to the Dutch translation to see if it works out that way the same. In my country, they say zwaartekracht, which means heavy force, so literally. So we translate it differently, and that brings a whole different load to the word zwaartekracht or gravity in my country. So, but if I look at these definitions, then yeah, it's the more I get it explained, the more it has no real validity for me or usage. I mean, I cannot explain mass anyway, and I cannot imagine that anyone else can explain it properly. Because yeah, weight has something to do with it as well, and I don't see the word weight in with the mass. So yeah, it's convoluted for me. So difficult. I try to, but I think it's in the equations, isn't it? That mass thing. So they need it for the equations to work.
Well, like Adam's just pointed out, they need it to swindle in the downward force, basically, don't they? Because
Yeah,
we've got
yeah.
to have a downward force to keep us on a spinning ball and not have everything flying off.
Exactly. Yeah.
Any more for any more? If not, we'll move on, John.
Outstanding. So I'm going to take a little sidebar here. Like I said, Newtonian Cavendish gravity is dead. It's DOA. If you haven't realized that by now, then I don't know what to tell you. So let's go off to another subject here with Newtonian mechanics in general. All right, let's take a look at this and see if we can't reason amongst ourselves. So, Professor Shankar, Chair of Physics at Yale, listen to these closely. All right, so today we're going to shoot down Newtonian mechanics and Maxwell's theory. We're like the pressed. We build somebody up only to destroy them, right? We're not going to get into Maxwell just yet, but just keep in mind he's down the tubes also. It's Newton, Einstein, and Maxwell. That's who quantum mechanics takes to the woodshed. Quickly. So the next one, first I want to tell you what goes wrong with Newtonian mechanics. The double slit experiment is a problem. That's what puts the nail in the coffin for Newtonian physics. Now, why is he saying that? Well, let's say we have a double slit experiment with a Newtonian particle and electron. We close one slit and fire a bevy of electrons and we get 10 hits at point A. We close that slit and we open the other slit and we fire a bevy of electrons and we get 8 hits at point A. The Newtonian prediction would be if we fired the same bevy of electrons with both slits open, we must get 18 hits at point A. What do we get? We get a big fat 0. And what does that mean? Chair, Professor of Physics at Yale, go ahead and tell them that is the end of Newtonian physics. Now, I realize that I have problems with interpretations, so let's consolidate these and see where we come out. So, in relation to Newtonian classical mechanics, every time you hear classical mechanics, it's synonymous with Newtonian. They're saying the same thing. So, what do shoot down, the nail in the coffin, destroy, and that is the end of actually mean? The mindless retort, I've been getting this for about a decade. Wow, quantum mechanics doesn't apply to big things. Really? Oh, what do you have to say about that, Professor of Physics at Yale? The laws of physics are always quantum mechanical laws. Here comes the punchline. You don't have separate laws for big and small things. That's pretty clear. From Lapwix, 2011, experimental non-classicality of an indivisible quantum system. They state, our results illustrate a deep incompatibility between quantum mechanics and classical physics, i.e. Newtonian physics, that cannot in any way result from entanglement. From the Bulletin of the American Physical Society, in Seed magazine, late last year, Bruckner-Koffler showed that it does not matter how many particles are around or how large an object is. Quantum mechanics always holds true. Always.
John, can you just go back to the previous statement of entanglement and maybe
Sure.
just explain that? Because I think that's quite...
We're going to get into entanglement down here in a little while.
Okay, yeah.
So we'll get into that here in a few. So just hold off on that. So what he's saying here, it doesn't matter how large, quantum mechanics always holds true. Well, why can't we see it? Well, because it washes itself out. Because our vision is not attenuated enough. That doesn't mean it's not happening because you ain't seeing it. Right? The current record holder, and this is of 2013, and I have to be honest, I haven't looked recently, but I'm going to. Probably tomorrow or the next day. I'm going to go look. It's going to be bigger than this. So the current record holder for from 2013 for quantum interference. We're not talking about electrons or photons here. This is 10,000 atomic mass units. This is massive. Huge. Right? And then the coup de grace. I'm going to end it quick, put you out of your misery. From the parent paper, O'Connell, the quantum ground state and single phonon control of a mechanical resonator from Nature, a metal paddle that's 30 micrometers long. That's trillions of atoms. A team of scientists has succeeded in putting an object large enough to be visible by the naked eye into a mixed state, quantum state of moving and not moving. This is over. It's over. Period. So goodbye, Newton. All right. I want you to sing it with me now. Ready? Turn out the lights.
Oh God, no! God, no!
Oh God, no! Please.
Yeah,
They say that all good things must end.
Kick 'em.
Okay.
Oh,
So,
Love a bit of country.
Kick 'em.
Love a bit of country.
yeah, I'd rather hear the
Somebody
actual
please
death
kick
throes of Newton. But yes, so bye Newton. Goodbye forever, Newtonian.
Yep.
No, sorry. Anybody who still adheres to Cavendish gravity. What was it that? Sorry to get his scrolling right back to the beginning. What was it that Newton himself said about it?
Oh, you want me to go back up? Yep, I can do
I
that.
mean, smart guy, given this quote.
Yeah, let me read this again. Adam didn't hear this. This is a letter to Richard Bentley on February 25th, 1692. Isaac Newton says, and this is 5 years after the Principia was published. Isaac Newton says, "'Tis inconceivable that inanimate brute matter should, without mediation of something else which is not material, operate upon and affect other matter without mutual contact. That gravity should be innate, inherent, and essential to matter, so that one body can act upon another at a distance through a vacuum, without mediation of anything else, by and through which their action or force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into."
It's one of those ones that when you look at it honestly, and maybe not in your presentations, but when you do go off and you do, we in Iron Realm stumbled on that quote a long time ago, and it's one of the things where I hate to get a bit of mud floody in the perversion of history. It's very, very interesting that somebody that has all of this physics ascribed to him could make such a statement on his own, and most of the ascribing of the statements of Newton are ascribed to him, not necessarily his. Very interesting that the man himself made that statement, and they're one of the things that really as an intellectually honest person, if you are just looking at this from scratch, this is the greatest teacher of it, and they're his personal opinions on this theory, you really should pay a bit of attention to his full assessment of the theory. And it's that last bit, so great an absurdity that I believe no man who has philosophical matters of competent faculty thinking can ever fall into it. That is quite a statement to make with regards to your own piece of Nobel Prize winning, if that was ever, you know, which obviously were around then, but Nobel Prize winning physics, to have made the statement yourself that basically it's a bag of shit and you've got to be absolutely nutty to believe that you've got invisible forces acting on things through a vacuum. He's quite clear.
I agree, and I like your word ascribe to him. Exactly.
Yeah.
That's why I hold back on, just in the context of gravity, dogging Newton out too much. Because I think it was ascribed.
With most of the theoretical physics stuff that we see, particularly Cavendish, everything's ascribed. It's very difficult to find these individuals themselves making these claims. It tends to be ascribed after the death, posthumously. We happen to have found the crazy workings of this guy buried in a book, in a case at the back of his bookshelf, which describes the experiment. I mean, that is the Cavendish experiment itself in a nutshell. It was never there. It was never observed by anyone. It's the repetition of apparently the recordings of a lunatic recluse.
Yeah, I agree. And it's 100 years after Newton, right?
Yeah.
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 Can I ask a question?
Go ahead.
About, I want to ask a question about Newtonian, classic Newtonian physics, whatever. I mean, I hear people say, well, it still works, right? That's what they always come back with. Because you have these three Newton laws. Is that also meant by that? Or is that something that we still ascribe by? Or is it just a Newton gravitational law that they refer to?
No, quantum mechanics is just Newtonian mechanics. It's the whole thing.
The whole thing, also the three laws of motion.
Yeah, it takes the whole Newtonian mechanics. It says Newtonian mechanics, and then down here it says Newtonian physics. That's the whole thing to me.
See, I've never understood why ballers think that this way in which Newtonian and Einsteinian stuff matches up is in any way kind of a proof, because you start with the concept of dropping a ball and measure that rate of drop, and it works out 9.8, whatever. And then from that, you develop mathematics based on a principle of a interacting force. But the starting point is the physical measurement you've got of 9.8 drop that you measure.
Yeah, you're all over.
You then go off on another route and you say, no, it's the interaction of a space-time.
Yeah.
And I'm going to use this mathematics, which is based on a drop rate of 9.8 meters. Of course, the two bloody match, because they're both based on the only thing that they have in common, which is the actual observation made in reality.
Adam's got it. They backward engineered them.
Yeah.
That's all they did is backward engineering. You're just taking it a fact, right? You can backwards engineer any mathematics, right? Yeah, you got it, Adam. Good on you, sir.
You know, I'm sorry.
No, go ahead, Slick. I was just saying I'm glad you're here, Adam. Very cool.
If I was a prosecutor in a courtroom, and let's say I put a witness on the stand, say a Timmy Osmond or somebody, and I put him on the stand, and I had him read that very first part where Newton was basically denying what mass could do. I mean, to me, right at that point, I would be like, no further questions. I'd rest the whole case. Take this to the jury. I mean, it's right at that point. It's already over. Everything past that, it just means nothing after that. I mean, that's just my take on it.
Yeah, you're twisting the knife. He's definitely had all of his nonsense killed in the last hour. What do you reckon, John? Should we pummel Einstein?
Oh, yeah. We ready to move on?
I think so. I think Newtonian Cavendish nonsense has been absolutely smashed to death. Let's move on to Einstein.
That's all right. You're going to get it on Monday. Somebody's going to come in and call, bring up Cavendish and a force. It's just going to happen.
Goes without saying. Right, you're up.
All right. Yeah, let's move on. So since we pummeled Newton, we don't want to give all the pummeling to him. Let's go to Einstein, our favorite guy. I think you were compared to him a couple weeks ago. So I guess he's your buddy. Let's go ahead and take the most famous equation, right? Hands down, everyone. You'd probably ask anybody, and they'd at least seen this before, right? E equals mc squared. Well, number one, this is horse pucky. Number two, equations can't explain anything. At best, they can only describe. This particular equation is a fairy tale, and you can ask. If you ask any mathematician, they're going to tell you each variable in the equation, in any equation, must be defined rigorously. Everyone knows this. So, A, this is my questions when this is brought up. A, define energy or define E, that's energy. B, define mass, and it's not volume times density. Listen, if I ask for a definition, I don't want an equation. Right? If I ask somebody what a banana is, they're not giving me an equation back, right? And define C, the speed of light. So for A, let's go to Richard Feynman, Nobel laureate physics from the Feynman lectures at Caltech. In regards to energy, it is important to realize that in physics today, we have no knowledge of what energy is. You're not starting off too well. B, mass. Do I really need to go through this one again? I don't think so. And C, the speed of light is merely a convention that we've agreed upon. So this is a train wreck. This is train wreck, people. Unless you got something, unless you can send me something, it's out the window. I thought I'd bring that up just as a primer. Let's get into the business. So, relativity, special relativity and general relativity via different mechanisms, speed versus gravity, can dilate, bend, or warp time. I want some of the shrooms you guys are smoking. Number one, primary school falsification. Time is a conceptual relationship between two motions. Specifically, it's based on an alleged single rotation of the Earth on its axis in respect to the sun, a day. Time is a concept. It's non-physical. It is without chemical formula, structure, charge, mass, momentum, or spin. No millielectron volts, kcals, or kilojoules. No dimensionality or orthogonality. No direction or location. You can't put time in a jar and paint it red. I mean, come on now, let's reason together. Can you dilate, bend, or warp non-physical concepts?
I have a real problem with this one, John.
Hold on a second.
Yeah.
Is it your contention that if you have poison ivy on the brain that you could scratch it by thinking of sandpaper? Freedom is a concept also. Can you bend that? That which you are using to measure isn't the thing you're measuring. A football field, American, is 100 yards long, but a football field isn't yardsticks. If I bend the yardstick, does the football field bend also? So if something affects, say, a cesium atomic clocks, or any modern clock for that matter, does that then ipso facto mean the Earth's alleged rotation in relation to the sun is affected? These two mathematical fairy tales, special relativity and general relativity, were falsified 30 seconds after their respective publications by third graders at recess, for goodness sakes. In toto, each are massive reification fallacies on steroids. That's it. Go ahead, Adam.
Just scroll up. This is that first line. Time is a conceptual relationship between two motions.
Yeah.
I was a big Doctor Who fan, and the thing that got me into that was Planet of the Apes and the people traveling away and time being relative there. And it's something I've never got to grips with, but from a scientific study point of view, I've always tried to look at it from science's point of view and look at how you can vary and manipulate. And to me, time has no relation to physicality. It is solely a man-made concept. Whether it has any relevance to the fabric of reality is, to me, even greater conjecture, because it is a concept of man.
I agree. I like to define it as the conceptual medium in which all events in what we call the universe takes place.
Right, I just want to add something there. So, brief history of time, Adam. Red Dwarf, Doctor Who. They're basically poster childs for that.
Yeah.
All of the concepts and ideas come from there.
Yeah, and all of that is a bit like John's analogy there, where we're in some way, by walking along the tape measure, that in some way then relates to our position on the football field. The two are very different things. One's a concept that relates to the physical reality. The measuring of the football field, we have a much greater grasp upon, because we actually are able to measure the dimensions of the football field. We can go back, we can measure up to here, we can go back, we can measure from here to there. Time is just something that we pretend we understand, but can only measure what's gone. We can't go back and remeasure it from that point. Therefore, we have no control over it as a measurement like we pretend we do with regards to other physical measurements. It isn't a physical measurement. It's a mental construct, time.
Precisely. It's been reified into textiles, right? So you end up with time being part of a fabric.
And hey, also, isn't everything in the universe, I think I've heard somewhere where it says everything is made up of either matter or energy. Now, time doesn't include in any, either of those two things, right?
But colloquially it does.
You're
Even
subject there.
even in Adam's language, you almost said the fabric of our existence, I think was how you phrased it. Well, the fabric of space-time is where you have that reification in your language.
Well, that's why I said it like that, because we talk about space-time as if space, which we can all measure, feel, measure, and time, they've integrated the two. And with Doctor Who, Red Dwarf, all of those things, we're colluded into talking as if space-time is a real thing that we're able to verify. It's a concept. Space is fine. Time is a concept. The two, I'm yet to see anybody demonstrate in any real sense how they interact with any scientific principle. You can't vary it. And like I say, time is a concept to me, which is why you don't really use it scientifically to prove and validate stuff. In the truest sense, it's not something that's variable. It can pass and we can say it's gone X amount of time, but we can't vary time.
It's science fiction, basically.
Yeah.
And that's, I like the science fiction of things. And when I found out that the whole Star Trek Voyager, when they were lost in the sort of a delta quadrant of the universe and wanted to travel back, I was mystified, because I knew that they never could come back in the time where they came from, or the same time that they came from. And that basically destroyed my whole belief in the Star Trek Voyager series. And that was basically the beginning of the whole falling down of my heliocentric belief, basically, because of that time concept. It can't be that way, that if you travel from Earth, if that ever was possible, and come back, and that the Earth has progressed many more years than you have, because that's the concept, basically. And it mystified me. It didn't sound real. So The whole time
That's
thing, it's more a philosophical thing than real thing. Too.
Yeah. That's special relativity, and you're right. It's philosophical because Einstein was a philosopher with a calculator. Yeah, that's what he was. You're right. It's philosophical, and they use that example, the example you were talking about, to justify or prove special relativity.
But he didn't ever had a peer-reviewed citation of this, right? So he didn't really put that through the whole system.
What system? Peer review is not part of the scientific method. We went over that last week.
Yeah, but even that he didn't do.
No, this is not experimental based. No, absolutely not.
Because he knew that it would be, discarded maybe.
Or maybe that's a good point. Just before we move on to say exactly that you're never going to vary time. Well, how is that relevant? Well, if you're going to formulate a scientific prediction, otherwise known as a hypothesis, and you're going to claim that time is causing things, well, as Adam rightly points out, you can't vary it. It's never going to be your variable in any experiment. It can't be.
Well, not only that, it can't cause anything.
Right. Well, yeah, I'll just ring out with the globe head. It causes all things, John.
It's a consequence of the mathematics. By trying to integrate space and time as a consequence, or with gravity being the consequence of integrating the two parameters, where we don't understand time, and building this space-time fabric, which we all understand that map where the grid lines are bending. The consequence of building that mathematical model is that mass does have a reflection on local time, and therefore if you are in a particular region, then the whilst you don't experience it personally in this theory, the consequence of somebody in another place where there is a different bending and warping of that space-time is you will experience local time differently. That isn't anything that anybody's experienced. It's something that came out of a consequence of building the mathematics like that. When they put the mathematics together, it became apparent that actually time would run differently in different parts of space because of the integration of both space and time to merge and give a reason for gravity. So all of this science fiction time travel bits is just a fairy tale based on the consequence of the mathematics of building the model like that.
Right, but from that fairy tale, you get some great sci-fi concepts, right? Wormholes and time dilation and all kinds of groovy crap that they claim is actually our reality, but it's just a good sci-fi story.
Black holes.
Black holes,
right?
Yeah, there's another one.
White holes.
Yeah.
They're all mathematical consequences of enforcing that space-time structure upon the universe. Sure. They become mathematically possible and sometimes have to be true. They have to exist like this, just like dark matter has to exist for the whole model to be held together, because if it doesn't make sense. So there has to be this thing here. There has to be things such as wilds because mathematically they exist as a consequence of building the model based upon the presupposition that space and time lend to the formation of what we assume is gravity. That's the consequence of it. It doesn't mean it's real. It's just a mathematical theory that evolves when you come out with the numbers. Don't pick me up on that word. I was just being, it's a consequence that then the imagination then has to fill in what those numbers then mean in reality, what the consequence of those numbers would mean. Nobody's observed it. It's just those numbers are there, and therefore we try to fill in a reality to match the numbers. We've got a wormhole.
Yeah, but why do we have a mathematical scientific theory? It shouldn't be that. Shouldn't that be the first question?
Yeah.
How in the world do we have a mathematical scientific? It's nonsensical. Is germ theory mathematical? Can somebody give me the equation of germ theory?
Yes. No.
I got a question.
Yeah, that's where we're at. That's the position that we're at right here. It's non sequitur on acid.
I have a question, and I'm just sitting here thinking about this, and tell me if this makes sense. If everything consists of either matter or energy, well, gravity would have to fall under one of those categories, and it's not matter, so it would have to be energy. Now, if gravity is energy and mass is what causes, matter is what causes gravity, then that means that every piece of matter is energy at the same time. Is that making any kind of sense? I'm just trying to wrap my head around that thought. Does that sound right?
Well, yeah, but you've slipped gravity in there unnecessarily, which is precisely
No,
what they
no,
do.
no, no. When I'm arguing this from the ball people perspective. That's what I'm
Yeah.
saying. See, if everything can only be matter or energy, well, on coming from them, then gravity would have to be energy. But if mass is what causes gravity, that means that all mass is energy and matter at the exact same time. According to them, that would be the story that they would have to back because that would be the case.
I guess so. I mean, you've illuminated things even less, which the ballers will love you for.
Well, they're materialists, so they think it's matter, and things have to be realistic, right?
Yeah, sorry. I'm sorry. I heard you.
But
from
I think where they
I heard you from a distance. I just got back. There was about. I don't want you to say it over again because it's limited in time, but there was some begging the question fallacies and some errors you had in your statement right there because they can't even define mass, right? We already been through that. And gravity doesn't exist. So we're trying to figure out, trying to reconcile what invisible three-toed gnomes are. Is it matter or energy? And what's energy?
Right, but John, you don't understand. I'm talking about from their point of view. They're the ones that's claiming gravity. And what I'm saying is, if all there is matter and energy, then gravity would have to be energy. And if mass is what causes gravity, that means that all mass, which is matter, has to be matter and energy at the exact same time. That's my point. That means that there's no separation between matter and energy according to the globe heliocentric theory.
Yeah, there's a lot of problems with that. But yes, matter and energy are equivalents, right? But what's energy?
No, what I'm saying is that things can either be matter or energy. It has to be one of those two.
No,
Okay.
but there's, sorry to interrupt, there's a serious reason why. Just listen to his question again, Slick, and then try to answer it, see how you get on.
Okay.
Yeah, my question, you said you're right. Everything is either matter or energy, right? Okay, what's time?
Time has nothing, that's not a part of the equation. It doesn't equal matter or energy.
That's right. So then they're off the reservation to begin with. Materialism's done. What about
Right, but
knowledge?
that's what.
What
I'm sorry,
about
go ahead.
information? Does information matter or energy?
Well, that's a whole nother. I couldn't answer that one.
That's what I'm talking
Right.
about. We're getting down this road. Exactly.
Materialists, that's what I said.
Exactly. Yeah.
But I'm only talking about the matter energy concept.
Precisely.
It just makes,
Yeah, but it
Exactly.
doesn't fit in the whole gravity space-time thing with Einstein, right? So
but I'm just thinking Newtonian. I'm just thinking even on that level.
well, we
it just
included
won't work.
Newtonian already. You're too late.
Come on,
You're too late, Slick.
twisted
You
the
know
knife
what?
on
Somebody
that
been
one already.
destroyed. Come a
Y'all
little bit
kinda
late to the party.
You're kind of missing the boat. Don't worry about it.
All right. That's all right. Hey, that's all right. Can we move on?
Yeah, I think
No,
so. I mean,
just one second, because I'm fumbling with Slick here. So for me, it is probably what I was trying to say earlier. They've tried to crowbar time into the fabric of reality to allude that somehow now matter bends time, and in doing so time therefore bends matter to allow for gravity. That's it's got nothing to do with it. The two are reciprocal and just kind of cancel each other out. There's no cause of it. It just happens. It just is, because time bends like this, but you don't experience it because it's local. But that's the reason for gravity. But it kind of cancels it. It's might be a bit simplistic, but it kind of cancels itself out in terms of the theory, and you just have to accept that it is there, because you can't put anything on the time component, measure or analyze it. So you just have to accept that it is there. And that's why gravity is there, because time does bend like that because of mass.
Yeah, that's Jeranism did a really good video on Einstein's transform equations, which is essentially what you're describing, right? Where you engineer it in and then just engineer it right back out again.
Yeah. Bit like
All right, we good?
We're good. Yeah, let's move on.
All right, so we already did the primary school falsification. I could stop right here, but where's the fun in that? Let's do the grown-up falsification, and I shortened this by quite a lot. I just used the, I tried to keep it concise, but yet still have the Louisville Slugger. So, non-locality occurs due to the phenomena of entanglement, whereby particles that interact with each other become permanently correlated or dependent on each other's states and properties, to the extent that they effectively lose their individuality and in many ways behave as a single entity. So because of this well-established phenomena in 1935, which pummeled Einstein's fairy tales, GR and SR, he coined the phrase spooky action at a distance. We've all heard this before. Then he and his buddies conjured a thought experiment. This is the EPR paradox of 1935. EPR is Einstein, Podolsky, and Rosen, in a feeble, clumsy attempt to debunk quantum mechanics. Why? Well, he couldn't have anything traveling faster than the speed of light, because his theories would implode. A side note with this, he never published in physical review letters again because he didn't appreciate the paper being peer-reviewed. Continuing on. Because of the seemingly impossibility of testing his thought experiment, it apparently covered the pretentious, pompous, pseudoscience, mythomathematical philosophy, but almost got that out, and the very public argument between he and Niels Bohr, who was of the opposite position, was relegated to the dustbin of history, never to be falsified. But then, in the 1960s, John Bell explored Einstein's alleged paradoxical thought experiment above and proposed an inequality. It's called Bell's inequality. If it was shown to be false, Einstein and his theories would take a dirt nap. Then John Clauser, a frustrated grad student because of his poor grades in quantum mechanics, was rustling through some books and papers in the campus library when he came across John Bell's paper. And that, as they say, folks, is history. Bell's inequality was first violated experimentally in 1972 by John Clauser and Stuart Friedman. Then in 1982, physicist Elena Spey experimentally jacked it yard forever. Ergo, Einstein and his theories took a dirt nap. He got debunked. Ever since the Spey's falsification, non-locality has been confirmed by experiment over 3,000 times, without exception. So I'll stop quickly right here.
Okay. Well, I didn't interrupt you when you were talking about special and general relativity because you've abbreviated them, but people may not pick up on that. Nevertheless, minor point.
Yes,
So
yes.
this is first based on a thought experiment, right? The whole thing.
No, they're debunking. They had to debunk. See, they knew about entanglement back in the day. They had already experimentally validated it back then. That's why Einstein, Podolsky, and Rosen said, wait a second. We got to debunk this stuff, because the ramifications of it were that I don't know how they conjured this information. They just conjured that from nowhere. They conjured that it had to be that information was traveling faster than the speed of light. And you can't do that with special relativity and general relativity. It just cuts its knees off, both knees off at the core. That's why they did it.
But they couldn't show it then?
No, it was a thought experiment. It was a pretty good thought experiment, but they couldn't show it. They didn't have the technology back then, not 1935. No
Is
way.
that somehow related to Schrödinger cat also, or
With
is that,
Schrodinger's cat?
yeah, is that related?
Quantum
Or-
mechanics is all related, but it's not directly related to entanglement. No, it has to do with knowledge of the which path information.
I was
Yeah,
going to say,
well-
without summarizing the double slit quantum eraser, how can you summarize entanglement? Because people have heard now that term in the audience, and they may not know what you're talking about.
Yeah, that's what I was saying. That's why I explained it up here. So it occurs, dude. Entanglement is particles that interact with each other. They become permanently correlated. That means their wave functions are sort of like two separate wave functions become one. So anything that deals with one, you can have one particle here. This is how they describe it. You can have one particle here. Let's say you got two entangled particles. Let's say they're photons. It doesn't have to be, or electrons. And you keep one here and you send the other one to the other part of the universe, right? What they're saying is if you take a measurement of the one particle here, it immediately, instantaneously creates the particle on the other side. It'll give a certain result immediately. Instead of being this wishy-washy wave function, the wave functions of both collapse. Now the space between this particle here and the one 1 billion galaxies away, that's in their narrative, that's pretty far away, and that travels, if it's instantaneous, that's faster than the speed of light. So
But
Einstein couldn't have that.
It isn't the same as the twin particles. It is a different property because isn't it? Or is that not with the entanglement the case?
The twin particles, I'm not following.
Well, I had heard it explained the following: like you have shoes, left shoe or right shoe, right?
Sure. Yeah.
You put these in a box, you twist them around. Nobody knows in which box which shoe is.
Right.
And you send one shoe to the other part of the world. When you open one box, and it is the right shoe, you know automatically.
I see what you're saying. That
That's the other one.
That it's already predetermined, but that was debunked by Bell's inequality. Yep.
Okay.
And a number, what they call it is hidden variables or hidden variable theories. We're going down a rabbit trail here.
I was going to say, let me just bring it back on track. So basically, you've got a speed limit. Einstein has a speed limit, the speed of light. And that is completely negated if you have instantaneous action happening in two different places at once. Because obviously you haven't got a communication line at that speed limit because it's violated. There wouldn't be any quote-unquote speed between the two things at all. So it completely debunks the notion that you have this speed limit. That's
speed and time is space and time, distance and time.
Yeah, exactly. Yeah, and that's debunked. The space and time issue is debunked. Remember the delayed choice quantum eraser experiment? If space and time is utterly meaningless in this reality, and all you have to do is go back to the delayed choice quantum eraser presentation, and I explain in detailed steps why.
So if you want to check that out, it's in the info box. So just click the more info if you're on a PC, or the down arrow if you're on a mobile device, and I think it's called the Quantum Eraser Experiment or something like that, but it's definitely down there and fairly obvious and labelled, so just check it out if you want to see that video on the double slit quantum eraser. Anyway.
Really interesting.
The way I've always understood that is from the E equals MC squared equation, so that if energy, i.e. the total amount of stuff in something, whatever it's made up of, is equal to the mass times the speed of light squared, then suddenly if we disprove that things can go faster than the speed of light, then they either have to have zero mass or more energy than is contained within the formula. So by that, to me, the inequality stuff itself just shows that some things can go faster than the speed of light. Therefore, the definitive statement that E equals MC squared may apply a bit like Newton's theories. two observations, but it cannot be theoretically true because it's theoretically disproved by quantum observational experiments, which is it 3,000 times you've said there?
Yeah,
Does that make sense? That's kind of how I hold that bit.
Well, number one, 3,000 times. That's a conservative estimate because I just put that down there, man. It's just the way it is. It's experimentally validated. So I got tired of looking through them.
But what I mean is the speed of light. If you can prove that something goes faster than the speed of light, then it destroys the equation because
Yeah,
the speed of
I
light
was
is
What
afraid.
is the speed of light?
Yeah, because we got number one, we got problems with the speed of light because it's a convention. But other than that, we're going down a rabbit trail here that I thought that we weren't going to go down, but that's okay.
You should have had the speed of light thing in here. Too.
Yeah, I don't. Yeah, it would just be too long.
Yeah. Maybe for next time, maybe.
Well, no, it gets pummeled just by the description of what that actually is. You know what light actually is, and I'm sure that's coming up later, right?
Later in this presentation?
No, maybe it's in the quantum eraser experiment. Again, click the info box. Moving on.
Yeah, because this is a long or a deep rabbit hole.
Yeah, but this is a large study. I mean, this is something that's interesting, but it is a large subject. So.
Yeah, but let me just state this: that there is nothing traveling greater than the speed of light. Let me just say that there are other explanations that have been confirmed. Let's leave it right there. Maybe we could talk offline, Adam, about this.
Yeah. I mean, mine's not with any certainty. Like I say, it's how I'm reconcile it in my head, and some of the stuff, these experiments, I'm in terms of the Bell's inequality and some of the stuff you're talking about, the disproofs. It's way beyond my level, mate, and it'd be interesting to chat about that and go through some of the implications of them.
Sure.
Just to firm it up, yeah, because I said it's easy enough to have a basic understanding. And mine holds from, like I said, the basic maths that if you're going faster than the speed of light, you've got more energy. Well, Einstein's equation says that's limited by the speed of light, the total energy. So it disproves it there. And there may be more detailed stuff, or I may be wrong there, and I'm happy to be wrong. So yeah, I'd love to get schooled a bit, dude.
I mean, that might be a useful. That might be a useful conversation to be heard, because from what I'm hearing, you're trying to work this or undo this from within the concepts that Einstein lays down, Adam. Would that be a fair assessment, John?
Yeah.
Yes, I'm looking at the contradictions it has within itself, or the things that other parts of quantum physics says can happen.
I get it. I can just
equation.
I can help you out there. It's all bollocks.
Thanks.
Yeah, that's cool. Right. That's called a moment of clarity.
Yeah, it is. That's a good one. We ready?
I think so. Yes. I've had you up for a while.
All right. This is really good. Now, let's reason together. Right. This is going to be really simple. Let's try and take two interconnected thoughts that both of these statements are going to give us and see if we can come out with a coherent conclusion. Okay? We're going to try this, so pay attention. So from David Bohm, professor of physics and really good personal friends with Einstein, by the way. Let's see what he has to say. So one could see that relativity and quantum mechanics, the two most important fundamental theories of matter, really contradict each other in the sense that relativity is local, it's causal, it's determined, it's continuous, and quantum mechanics is just the opposite. And then we have Professor Shankar, the chair of physics at Yale. He says, the laws of physics are always quantum mechanical laws. So if the laws of physics are always quantum mechanical laws, and Einstein's fairy tales stand in direct contradiction to them, then where does that leave Einstein's fairy tales? We can stop. Go ahead.
I was going to say, I'm sure that's what I just said.
Didn't I just cover this?
Well, they're trying to marry these two now somehow, and with all kinds of things and holographic things and stuff. I don't like comprehend because it's all mathematical, but they try to make quantum mechanics work within the heliocentric thing.
Married bachelors.
I know, but they still try it.
Yeah. Okay, is that it for that? This is painfully obvious, right? But I was asking more or less that question rhetorical, but
That's why there was a long pause, but very dramatic.
and I had a PS here, and I put that here so I wouldn't forget something, and I forgot what the PS was. So that worked out real well. All right, we're gonna finish it up.
Cool.
Okay. All right.
Yeah, let's do it.
So let's tie a bow around gravity, both Newtonian Cavendish and Einstein's disheveled offerings, and pulverize them. And we're going to go, let's use Martin Rees, because he's another of these high pseudoscience priests of the ballers. So he was the astronomer royale with cheese, esteemed British cosmologist and astrophysicist. Check this out from Princeton Press. What causes gravity and mass? These questions still baffle all of us. You know, I first read this, I said, what the world? Right? So let me ask you this question. According to Professor Rees, does mass attracting mass cause gravity? Nope. According to Professor Rees, does space-time cause gravity? Nope. What on earth is going on here, people? Why am I even hearing anything about Newtonian mechanics or Einstein? Why with gravity? Somebody, he must not have got the memo, right? The astronomer royale, like, right? Yeah, sure. He must have been sleeping or something. Maybe he was sick. For goodness sakes. Oh, by the way, real scientific theories identify the cause of the effect. Okie dokie. The general theory of relativity is a theory of gravity, right? Allegedly a scientific theory, correct? So, ballers, you have a scientific theory without a cause? That's tantamount to ribeyes without cows and apple pie without apples. You've got nothing. Alice in Wonderland has more veracity. Gravity is merely a description of an effect, not a cause. Thanks for your ear. Have a nice day.
Good presentation. I mean, yeah, pummeling gravity is good fun, but as you rightly point out, you just know tomorrow someone will come on and say Cavendish balls is their scientific validity for gravity. It'll never end.
Yeah, it'll be Adam.
It'll be who?
It'll be Tuesday or Wednesday before I revert back.
It'll be Adam.
I mean, that was fairly thorough pummeling. There's going to be points in that people are going to lose track of what is actually being said and what it really means. And I don't know. Hopefully,
yeah, I tried to limit those, but some on the panel wanted to go down some rabbit holes.
No, that's not why. It's just because there's going to be certain people that work within those frameworks anyway. So that's why people won't detach themselves from Cavendish gravity, because it's, as Betty put it, it's used, it works. Nobody's going to necessarily go to the extent of figuring out how it's been engineered into something and isn't required, unless they sit through this show. Then maybe they will. But my point is that most people won't necessarily concern themselves with it when they're figuring out how many newtons a cargo ship weighs, right, Adam?
Sorry, muted. Yeah, I mean, totally. It's a con, isn't it? It's part of the paradigm they've painted us to make us feel intelligent, to give us this pretend knowledge that allows you, it's in newtons, it's a newtons load. When the reality is it's all a bullshit. A bit like listening to Fight the Flat Earth the other night with Anthony. That was a great example of somebody just repeating stuff that he clearly didn't fully understand. And I didn't fully understand what QE was saying there, but hopefully I've got the point off that there's enough you can pull out of these things without having to be at John's level to disprove what they're saying to you, the clear paradox of what they're saying, the contradictions of what they're saying, the impossibilities. And that's what I've took out of it tonight. Like I said, I do expect to get a bit of schooling offline or maybe even online on this, John. I'm happy for that. But to me, there's clear information there tonight that show the contradictions of what they're purporting.
I mean, I'm hoping we'll go through what's been said and hopefully summarise some of the debunkings. So, I mean, you know, in terms of how it gets debated about, when it's asserted that scientific validity is given to this this reification of a force that does not exist, a mathematical reification, is this set of balls in a shed, you know, and it's asserted that that's actually proof that that's scientific validity. It's an experiment. And for me, to round out at least on one of these points, hopefully a few of you pick up on one of the, or two or three of the others that John's brought up, and we'll go through those as well. But in terms of Cavendish, it's not an experiment. You know, I can hear the audience groan, but this is the reality. It's not an experiment. You can't manipulate the independent variable to cause the effect that you observe within the apparatus itself. And John had the fuss that is the hypothesis, otherwise known as scientific prediction, when they formulate it. In other words, we've put plenty of ballers to task to get them to detail how it is an experiment and formulate it into a hypothesis. And what you end up with is torsion bar twist. Well, torsion bar twist being the phenomena. Mass attracts mass, right? That is what it is describing. And then when you get them to describe what is actually being manipulated within the apparatus, otherwise known as a quasi-experiment, it's mass. So John put it up on screen earlier. You got if mass, then mass attracts mass. It's an absolute train wreck. The point being that you've not got an observed phenomena. You've not got a valid hypothesis. It's not science. So to assert it as such in the face of, again, John's presentation, which is far more, damning, not to mention the fact that Newton himself decries this whole idea of mass attracting mass. You've got the fact that the current scientists, if you want to accept them on face value within the heliocentric context, is the bending of the fabric of space-time, i.e. not a force. So the whole idea of having this Cavendish force of gravity is complete nonsense. And again, as John has smashed into the middle of next week on this very show, the whole idea of Einsteinian speed limits with light is just, again, a mathematical reification that isn't real. It's just, well, I'll say it again, it's bollocks. But anyway, hopefully someone else.
Cavendish, Nathan, for me, having someone that did it at A-level physics and 60 symbols on YouTube, the professors at Nottingham University, as they discuss it, is a great example. Cavendish is not only not an experiment when set up, it's not even necessarily a bloody effect most of the time when set up. You don't even get the effect, never mind have an experiment or anything anywhere near it. It's, for the majority of times, unless you're using polystyrene in a plastic bin, nothing moves.
I dig at Slice Arcane.
Nothing? No, I don't know. Just some dodgy experiment I saw on YouTube.
Not an experiment.
I know, thank you. It was. So to me, that's the important bit with it, mate. If even the thing that we're observing within the apparatus isn't necessarily observed each time within the apparatus. Cavendish.
Yeah, it's complete hit and miss. There's what is it? I forgot if it's 4 red candles or something like that. There's the guy explaining how there's a student hacking apart some Cavendish quote unquote experiment because he couldn't get the damn thing to work.
That's the lab tech on the professor saying, look, I've got this, and they're the ones that we did at A-level physics, those smaller Cavendish ones where you set it up. and he says, "Oh no, this one here, you can see the equipment working because we had some frustrated lab tech saw it in half because he couldn't get it ever to work." Do you know what I mean? So he shows you inside and out. It is just nonsense. And I always remember my physics teacher telling me, "Don't worry about doing that one. It never works." We did the dropping the balls and measuring the balls at 9.8, and when we did Cavendish, don't worry about that one, lads. It never works.
Hey, sorry, I was away from the computer and I heard Adam talking. Did you have something for me? Did you ask a question of me, Adam? Yeah, don't worry. Okay,
Would have
sorry
done, probably, yeah.
Yeah, sorry about that. I was away from the computer. I heard you and I started to run back, and then Nathan, I didn't want to interrupt. So
No, I was just trying to get some consistency in terms of purely because it will just come up tomorrow on the debate when somebody gets into the nitty gritty of this. I mean, back in whatever it was, 2015, I was unfamiliar with Cavendish. I'd never heard of it, and then when it was put to me, it seemed absolutely laughable, and I thought, well, no one's ever going to show that as proof of anything. And now when you hear it, almost daily, you just go, I can't quite believe I'm having to argue against this complete poppycock. But you do. And the thing we try and drive home constantly is that it's not an experiment. I've said it 3 times. And it's not an experiment because it doesn't have a valid hypothesis. And experimentation is the testing of a hypothesis. That's what an experiment is. It's a hypothesis test. So if you haven't got a valid hypothesis, and most importantly of all, you haven't got an actual phenomenon to do any research on, you're just creating it in the apparatus, then it's so far removed from actual science, it's untrue. It's just not valid. It wouldn't stand real scrutiny in terms of its adherence to the scientific method. It's not establishing the cause of an effect. You haven't even got an effect. What are you observing? Oh, well, I'm observing the Cavendish experiment, right? So there's no valid hypothesis, and this is often the case. Things are asserted to be experimentation when they're not. They're not actually hypothesis tests because there's no valid hypothesis. And in the case of Cavendish, when they try, the best of them try and formulate it into an actual hypothesis, they give you a mathematical formula and then claim that they've got 3 different independent variables, a contradiction in terms, which what drives me up the wall. Well, what's your independent, singular variable? Well, it's this, this, and this. No. Just one, your presumed cause, and that's it. End of variable. No more. It's just one. But then they'll give you 3 and claim that that's valid because the mathematical formula works out. And it's like, well, it doesn't need a formula. It's supposed to be establishing the cause of an effect. That's what the experiment does, right? Not lend credence to your mathematics, but that's all it really is. But yeah, so a lot of these debunkings for the scientific assertions that are put to gravity are undone by a simple question of, well, what is your phenomena? What are you actually observing here? What are you looking at? What are you trying to establish the cause of? What effect? What exactly are you trying to figure out? And they haven't got anything, right? They've just engineered it into things that occur anyway.
Yeah, they're whistling past the graveyard to begin with. Why are they even pulling up Newtonian Cavendish gravity? Their scientific community, it doesn't follow Newtonian or Cavendish gravity. So why are we even they're parroting the wrong pseudoscience. That's what's so funny. So
yeah, but they say that it is evolved into from one into the other.
It's evolved into it. Yeah.
Trigger word, huh? Evolve.
Yeah. It's evolved into it. I just don't. We just do it to entertain you guys. So, just continue to come in here and we'll just go ahead and bash you over the head with a shovel again. Mass attracts mass, right? Mass is the cause of mass attracting mass. So bring that on in.
I don't know if
we'll have a good time with that.
Will the struggle get worse as people actually start to adopt the more complex ideas that are the musings of a mathematician in the case of Einstein? Because some of those ideas, they're no more scientifically valid. There is no experimentation to go along with them. But some of the arguments might be a little bit more elongated if you're talking about more complex ideas. If you're...
I agree. I agree with you. But then all you have to do is go back to the hypothesis, to go back to the scientific method. If they want to bring up Einstein and you're unfamiliar with all these concepts, no problem. Scientifically validated, please. Natural phenomena observed, hypothesis. They can't do it. So just stay with the scientific method. You won't go wrong. They have nothing.
Right. I mean, Fight the Flat Earth and Sleeping Warriors debate came up from Adam earlier, and as much as I don't want to level any criticism at Anthony, because it was a good debate, both of them held quite a good account of themselves. I don't know if anybody will agree. I don't care either way. It's just my opinion. But had Anthony have stuck to the scientific method, it would have been a lot quicker. Let's put it that way.
Yeah, he's not the only one guilty of that.
Oh yeah. Not mention any names. That's fair enough. Long pause. I won't let it be anymore. Fair enough. Yes, but absolutely. If you've got something that's claimed to be an experiment, then you simply have to ask for the hypothesis, and therein will contain the phenomena and the thing you think is causing that phenomena. Now, if you have a valid hypothesis, it doesn't necessarily explain the thing that it's claiming, i.e., it is just a supposition. You have to back it with the main thing science is based on. Systematic experimentation based on a hypothesis. So, it's pretty critical. And unfortunately for Einstein, he doesn't have it.
Precisely. It's end the game, end the story. Yeah.
Cool. Slick?
No, I'm all set, thanks.
Betty?
No, I think that this was a great presentation, and I think that a lot of things were repeated over and over again, but I think that it's needed because people forget or don't grasp everything. So how many more times you show it, the more it will settle in and sink in with a lot of people. So great.
Yeah, I mean, I'll come to you in a moment, Adam, as well. Obviously, I won't forget you. But yeah, big kudos, John. I mean, I've watched this presentation on Cathexis' channel. I've watched it on my channel when I've watched the Gravity presentation before, and I've ultimately watched it now. And I've rewatched those exact same shows over and over again because it isn't easy to let it sink in and permeate your consciousness to the point where I can spot that Adam's working within Einsteinian concepts when he's describing something to try and undo it. You know, that isn't something that just comes naturally. It's something that is acquired from watching Nathan Oakley's videos over and over and over again. So I strongly suggest that everyone in the audience does exactly that. So yeah, Adam, did you have any last words before we round out in seriousness?
I'll defend that position because I think for the majority of people, we are brainwashed and brought up in that system. And I think the first step sometime, certainly for me, well before Flat Earth, this is talking, you know, the alarm bells are seeing the contradictions that if something can go faster than the speed of light, that kind of knackers that equation, doesn't it? Because you've just said the total amount of energy is based on that. So I'm not apologetic for it. I'm just trying to understand that actually within, you don't necessarily have to have stepped outside of the system to see its corruption. You can see the corruption within the contradictions that it speaks quite happily as a first step. And the stuff John was going through, I really enjoyed. And like I said, I do want to get a little bit more educated on that. Then allows you to the next step. If you really wanted to take people's arguments apart, I don't think you necessarily, as John's shown tonight, by just sticking to the scientific method. If you're unsure, just stick with that simple process because you can't go wrong because it is validated, tried and tested, that method, and has a meaning. And if you stick to that, it's very hard for their bullshit to get past you.
Absolutely. Or from my side of the fence, or anybody who's debating the subject of Flat Earth, simply asking for the adherence to the method. I've never performed the scientific method. I'm no scientist, that I will happily confess. But I can very easily ask, has this that you present to me as fact of what you say been through the method that you claim when you use the word experiment? And if the answer's no, I can say, That's nonsense. That's not science. That's pseudoscience. John, have you got any last words? If not, we'll round out.
Nah, that's it, man. I'm dying of hunger. I'll tell you what. Time chow.
Yeah, well, destroying Einstein, Cavendish and Newton is very hungry work. So with that, I will say a huge, massive, enormous thank you to Slick James Johnson, Adam Meakin, Betty Van Velsen and Quantum Eraser for making this Ballbusters possible. And of course, a massive thank you to all of you in the live audience for tuning in, smashing the super chat and hopefully sharing this live Ballbusters. I've been Nathan Oakley. Be sure to check out the nathanoakley.com Flat Earth Debate Forum, and I'll see you all in the next Ballbusters.